Differentiate an implicit function, or a function where the dependent variable is not isolated to one side of the equation, is exactly the same as differentiating an explicit function with just one minor difference. Now, to look at what that difference is, let's take the following equation for the unit circle: x squared plus y squared equals 1. To look at how to find the derivative of this function, let's take the derivative notation dy over dx. Because y is in the equation we're trying to differentiate, I'm going to go ahead and replace the y with an f of x, just to keep it a little clear. Using the derivative properties, we can find the derivative of all three of these terms individually, and then just plug them into the equation as they are. So first we'll start with the x squared. In this case, we have the same variable in both the numerator and the denominator, which means we don't have to do anything special with this function to find its derivative. So we just take the 2, pull it in front of the x, and subtract 1 from the power, giving us 2x as our derivative of x squared. Now, to find the derivative of y squared is a little more complicated. And the reason it's a little more complicated is because we don't have the same variable. In the numerator we have a y, and in the denominator we have an x. We still find the derivative using the power rule, so we take the 2 in front of the y, and subtract 1 from the power. So the derivative is 2y, but because the variables don't match, we now have to multiply it by dy over dx. This only leaves the 1 that we have to find the derivative of. So we go ahead and plug the 1 in. The derivative of any constant is 0, so the derivative of 1 is just 0. Now that we've found the derivatives of all three of our terms, we can go ahead and solve for dy over dx and find what the change in y with respect to x is for this equation. First step is to go ahead and subtract 2x from both sides of the equation. Then we go ahead and divide both sides of the equation by 2y. 2y's on the left side of the equation just cancel each other out, and then on the right side of the equation the 2's cancel each other out, leaving us with dy over dx equals negative x over y.